Okay, quick description. I have a magnet on this wheel. Wheel spins pretty good. Just have one magnet standing up. I'll take the camera off after and give a view of what's going on. Then I have a vertical wire here where I'm just pulsing about 150 volts across this wire to see what the rotor does with one magnet. It takes 70-80 volts to really get some movement out of it. This is 26 gauge wire. I have one pole facing out here. Alright, so what I'm going to do is I'm going to turn on this power supply. I have to monitor the supply because it'll do over 200 volts into this cap slowly, but the cap is 200 volt cap. Now what I want to show is I'm going to put the wire magnet right in front of the wire, and we're about 160 volts. I'll take it up to 170 and I'll hit it, and you can see that the wheel turned and actually the wire moved. So this is just a preliminary quick test thing after getting frustrated with another project. But what I noticed here is if I put the magnet just before the wire, we're about 150 volts right now, slow charge, 470 microfarad cap, 200 volts. Alright, approaching 170. I don't know if the camera is going to pick this up, but now what I see is the magnet is getting pushed away from the wire towards the inside of the wheel. I'll move it closer and try it again. Hopefully it doesn't move the wheel. About 130, about a millimeter away from magnet to wire. 160. I'm just shortening this out by hand, dumping the cap into this piece of wire. Alright, 170. Okay, now what I see is the magnet gets pushed this way. Now if I put it just after the wire, this is I'm reverting to some simple experiments with current magnetism through one wire, how it affects a magnet, or how the wire, if it's not mounted properly, moves with a magnet. Maybe right now we have kind of both moving, but I just thought this was kind of interesting here, and I'll explain after. And here we go. Now it pulled the magnet this way. So let me turn this power supply off. Okay, take the camera off. You can see here, it's just a, I think it's 1/2 inch by 1/8 by 16th magnet. I have to measure it. But then I just have this wire. Let me give a full shot. This is a little inverter, pocket inverter from Radio Shack, going into rectifiers, charging up the cap, and this wire goes over here just for measurement so I can see what the voltage is, and then I'm just tapping this here, ruining this little connector here, but it's a sacrificial connector is what that is. But what I'm seeing is if I have the magnet right upon the wire. Now if I hadn't made this all loosey-goosey with the tape here, I wouldn't have seen any of this stuff. I'd be just saying, okay, the wheel doesn't spin here and the wheel doesn't spin here, but it does here. But being that I have it all bendy like that, I can actually see what the magnet's doing, what kind of forces are put on the magnet. And if I put it in front of the wire, pushes it this way. And if I put it after the wire, pushes it that way. And if I have it right on the wire, it pushes it this way. Okay, so before the wire, pushes it this way. After the wire, pushes it this way. I don't think I got my fingers in there good before. If I have it right in front of the wire, pushes it this way. Alright, so what that means is if this wire had enough current through it to make this wheel spin, afterwards it's pulling on the magnet. So there's a spinning magnetic field, or let's say a circular magnetic field around the wire, where when it's here, that magnetic field is pushing on the field of the magnet this way. When it's here, the field around the wire is going around, it's pulling on the magnet. And when it's in front, we have the field around the wire pushing on the magnet. So that's just some basic stuff. I'm going to expand on that because I made a toroid coil around a plastic ring. Here it is. And it's bi-fi wired, but I hooked it up in series, parallel, everything, and had some magnets on here. And I thought that they would spin, being that if the magnet is in front of some of these wires, that we'd see the same thing here, pushing. But maybe there's too much pushing and pulling. I'm not sure. I have to work this out. But with this, putting 200 volts to it, I get nothing with 4 magnets going around the wheel. And the previous wheel was this one here, but the bearing on this, I don't have the original bearings for this wheel, and I did this project a while ago, and I put this particular bearing in that's, I can't get the grease out of it, so it's pretty tight, so it doesn't spin very well. So then I made this little plate, 16th inch plexi, a bearing that's all cleaned out, spins pretty nice, easy, but just wanted to show this little experiment. So I'm going to have to try a couple of wires, maybe 2, 3, 4, and maybe the magnet moves here and gets stuck in between. Moves here in front of the next wire, but gets stuck in between. And that might be why this isn't working. To move it, maybe I need thousands of volts to make this work, because there's really not that many windings in front of here. I'm dumping a 470 microfarad cap into this piece of wire with all this resistance crap going on. You know, I could make that more efficient and get more power here, but not much movement. You know, nothing to say anything about for how much energy we had to dump. So with this thing, you divide that voltage up amongst all these, and maybe there's 4 or 5 windings right in front of the magnet. Even with 4 magnets, it's not much torque. So probably one more experiment would be to put a whole bunch of very fine wires in parallel, and maybe that would equal something better than this. If I make it the same size, because you got all those little individual wires taking on the current and maybe building a better field. Not sure. But anyway, just wanted to show that.